Remember when we said we want to calculate the moles of anesthesia they're giving to this child here? Remember that? We said we want to calculate the moles of anesthesia they gave to this child here. We didn't do that yet, but we are going to do it right now. So I just wrote this out. I'm assuming that they are giving either ketamine or midazolam. And let's just assume the child is like maybe 20 kilograms. So here is the pediatric dose for ketamine here. It's just 1 milligram per kilogram. And we know multiplying 20 kilogram by 1 will be 20 milligram because multiplying by 1 will never ever do anything because 1 is a multiplicative identity. So we got 0.02 grams, and the molar mass for ketamine HCl is 1371 over 5. You can search it up, I'm telling you the truth. So to calculate how many moles that they're giving to this child here, all we need to do is to divide 0.02, which is 1 over 50, by 1371 over 5. And this is very easy here because
dividing by a number is the same as multiplying by its reciprocal.
So this is 1 over 50 times 5 over 1371, which is 5 over this number here, which equals to this. So they're giving this much moles to this child here. And to calculate how many ketamine molecules they're giving, multiply this by the Avogadro's number. The Avogadro's number is this. 6 times 6.022 times 7.29, which is this number here, is equal to about 43.9. And you know, we have a 10 to the power of 23 and 10 to the power of negative 5 here. 23 minus 5 is equal to 18. So it's 43.9 times 10 to the power of 18. But in scientific notation, we will write it as 4.39 times 10 to the power of 19, which is the same thing. So they're giving this much ketamine molecules to this child. And if they're using midazolam instead, everything will still be okay because this is the molar mass for midazolam. The molar mass for midazolam is this number here, and the dose for midazolam is 1/10 milligram per kilogram. And again, if we assume the child is about 20 kilograms, we can do 20 divided by 10, or 20 times 1/10, which is 2. Because 20 divided by 10 is obviously 2. 2 milligrams is 0.002 grams, which is 1 over 500. In this case, to calculate how many midazolam, we take 1 over 500 divided by 3623 over 10. And this is very easy here as well because
dividing by a number is the same as multiplying by its reciprocal.
So this is 1 over 500 times 10 over 3623, which is equal to this number here. And that is equal to this number here. So they're giving about this much moles to this child over here. And to calculate how much midazolam molecules they're giving, multiply this by the Avogadro's number. 5.52 times 6.022 is about 33.3 times 10 to the power of, see, 23. This is a 10 to the power of 23 here. this is a 10 to the power of 23 here, and this is a 10 to the power of negative 6. So 23 minus 6 is equal to 17. So this is about 5.52 times 6 times 6.0. 5.52 times 6.022 is about 33.3. So this is 33.3 times 10 to the power of 17 midazolam molecules, but in scientific notation we write it as 3.33 times 10 to the power of 18, which is equivalent. So they're giving about this much midazolam molecules to this child right here. So we calculate the moles, and we're done. Thank you for watching, and we learned some math today.